In this video, we're going to look at factoring trinomials where the lead coefficient a is equal to 1. As you've learned previously, ax squared plus bx plus c is the standard trinomial form of a quadratic. If we want to make this a function, we simply will set it equal to f of x, or y, whatever you're using to represent your function, whatever your notation is. Ultimately, what factoring helps us with quadratics is establishing the roots of the equation. If you remember a quadratic is actually a parabola. So if I have a quadratic that looks like this, it's got two roots. Those are what are called zeros, roots or zeros. Now, when we set our equation equal to 0 as opposed to f of x, that's what we're looking for. And quadratics have three possibilities for solutions. We have the first one here, which you have two possible solutions. Then you could have a parabola that looks like this. It only hits the axis, the x-axis. Roots are based on the x-axis. One root. And we could also have a situation where the parabola itself, the quadratic, never touches the axis, and so we have no roots. So there's two roots, one root, and no root, or what we call solutions. That's ultimately what our goal is by factoring. So let's go ahead and just learn how to factor first in this video, and I'm going to show you two different ways to factor. I'm going to show you the quick way, and then I'm going to show you the longer way, which might make a little bit more sense. But just to get your attention, I'm going to try to make it a little quicker for you. Now, all of these, the lead coefficient is 1, so it's 1x squared. Excuse me. That makes it a lot easier for us because when a is not 1, if it's greater than 1, whether it's positive or negative, we have to actually employ a different method to solve. So let's get going. Well, first of all, we're going to break this into two binomial factors. Every quadratic that is factorable, because some are not factorable, can be broken down into two binomial factors. So in this particular one, our lead term is b squared. Now, the only way to break that up is b times b. As you can see, I've put that in the parentheses, b times b. And if you have any familiarity with flat factoring, then you've seen this before. The other term I'm going to concern myself with at the outset is 7. And basically, I need to know, first of all, what are all the factors of 7? Well, it's a positive 7. And to get a positive number, remember, factor means multiply. So it could be positive 1 times positive 7, or it could be negative 1 times negative 7. Those are the only factor pairs that are possible. So which one do I pick? Well, it's all going to depend on your middle term, plus 8. I need to find two factors of plus positive 7 that actually will add up to positive 8. And if I look over here, I've got my factors right here, positive 1 and positive 7. So positive 1, positive 7. And those are my factors. And that's one way I can factor a trinomial with a lead coefficient of 1. So let's try that again with number 3. So if I look at number 3, let's try this again. If it's factorable, then I have two binomial factors. I'm going to split it because m times m is the only possibility for m squared. So let's look at negative 90. Well, looks like we're going to have quite a few factors of this guy. Now, negative means if I get a negative number, I have to multiply a positive times a negative. So let's kind of go down the row here. I can either have a negative 90 times a positive 1, or I could have a positive 90 times a negative 1. Now, rather than wasting our time and factoring every single factor of 90, which is pretty tedious, let's look at our target. Basically, I'm looking for two factors of negative 90, one positive and one negative, that add up to 1. You can see that that's a positive m. Sorry, I covered it up, which means 1m. So what are some factors of 90 that are only one digit apart from each other? Well, again, we can go through the whole thing if we want to. I can do positive 6 times negative 15, negative 6 times positive 15. We can do 2 times 45, but I think our candidate is going to come from 9 times 10. I can either have a negative 9 times a positive 10 or a positive 9 times a negative 10. If you look at what I'm looking for a positive 1 because that's what's in front of the m. Therefore, negative 9 and positive 10 are my options. So it's going to be m minus 9, m plus 10. And those are my two factors. So that's how you factor using with a lead coefficient of 1. Now, if this is not really making a whole lot of sense to you, we can employ the practice of grouping. And I can show this to you using grouping, and it'll make sense exactly what we're doing. So let's go back and let's look at number 1 again. 2 and 4 I'm going to actually kind of leave out right now. Let's just look at 1 and 4. So I'm 1 and 3. So let's go back to number 1. Number 1 is b squared plus 8b plus 7. Sorry, I'm yawning. So when I factored, I do the same thing. I take the c term, remember that's your constant, and I find all the factors that can give me that c term. Well, let's look at number 1 and let's revisit. Well, if I wanted to rewrite this, I could do b squared. And what am I looking for? I need 8x out of 1x and 7x. Remember, 1 and 7 are the two factors that added up to 8. Well, the reason for that is when I multiply this out, I'm going to get plus, 1x plus, let's go back and let's actually use the correct letter, plus 1b plus 7b plus 7. All I've done, if you notice, is I've taken the middle two terms and written them in terms of the factors I found. I've split the 8b up into 1b and 7b based on my factoring here, what I found worked for 8b. Why does this help you understand how we come up with these guys? Well, let's think about what factoring is. Remember, when you have a greatest common factor between two terms, I'm going to consider each of these terms individually. I'm going to look at that group, and I'm going to look at that group. Not individually, each group. So let's factor. What can I factor out of the purple? What do both of these terms have? Well, they both have a b. So if I factor out a b, that leaves me with b instead of b squared plus 1. All I've done is taken these two and factor a b out. Now, let's do it with the second group. That plus sign stays. What do 7b and 7 have in common? Well, they both got a 7. I factor out a 7 from the b, that gives me just b, and 7 factored out of 7 gives me a 1. So I've grouped them. I'm now set up to where I can group. Let's look at greatest common factor now on a grander scale. What do both of these terms have? What do these have in common? I can factor out a b plus 1, right? And what's left over when I factor out b plus 1 here? A b. And what's left over here? A positive 7. And you can see that these are the same two answers. So I know I sound like Bob Ross, the tree guy right now, but I want you to make that connection between this method here, which you will get good at once you get more familiar with factoring, and this method here, which is the same thing, but it shows you why we can skip straight to this part. So let's look at number 3. Let's do the same thing. Let's break down number 3. Number 3 over here is I've got m squared plus 1m plus minus 90. Well, my two factors came out to negative 9 and 10. Sorry, I'm yawning. I put myself to sleep sometimes. That's just the nature of being a math teacher. So basically, I'm going to take the m squared, and I'm going to take that 1m right there in the middle, and I'm going to put some happy little trees there. Just kidding. I'm going to change it to negative 9m plus 10m minus 90. And what I've done here, again, is I've taken this one m and I've separated it into the two factors that I got. So let's look at these by groups again. I want to factor this out, something out of there, and I want to factor something out of there. So what comes out of these two terms here? My first one, I can factor out an m. That leaves me with m minus 9. A plus sign stays there. And then I'm going to look at my second group, and I have 10m minus 90. So I'm going to factor out a positive 10, and that's going to leave me with m minus 9. So for the finish, I'm going to yet use the greatest common factor yet again. So both of these have an m minus 9, so I can factor out m minus 9 from both of these guys, and that leaves me with m plus 10. And once again, you can see how these guys are exactly the same. So the first method I showed you, when you get really comfortable with factoring, you can start separating out. The second method is showing you how it works by grouping and splitting, which probably for some of you will be ideal until you get the hang of it, because it explains to you why we're able to do the first part the way we are. So hopefully this helps you out with your factoring.